Today, joining us for the 7 a.m. breakfast show will be Professor John Latanzio. Everyone, please welcome him onto the stage.
Yes, thank you very much for inviting me onto your show.
What do you look for in extraterrestrial possible planets?
We look for life-friendly molecules like water vapor, oxygen and methane. However, liquid water is also very necessary.
So, you work in a trio, right?
Yes, I work in a trio with 2 other scientists.
What has your trio managed to do?
We try to create a basis for questioning the existence of other life along with finding where it could exist.
How did this research begin, and why is it important?
Research comes from a very wide investigation of galactical evolution, particularly chemical evolution, which seeks to find knowledge about when in space and time the stars similar to our Sun may have evolved with the capacity of containing Earth-like planets within the orbit.
How do you calculate the number of extraterrestrial civilizations with whom we may be able to communicate?
Well, the Draco question is a lengthy string of symbols that begins with the average rate of star formation per year, the fraction of the stars which have planets, the fraction of those planets that can support life, and the fraction of those that can support intelligent life.
What else do you research that benefits this project?
Well, many scientists use a type of computer modeling to create a representation of the galaxy's evolution using data that is newly available. This comes from telescopes such as the Twin Gemini Observatory in Hawaii in Chile, along with space platforms such as the Kepler telescope.
Are there any other maps that you can use that will benefit this project?
A map of livability is commonly applied before a Kepler telescope is used.
Who created the map of livability, and how?
Professor Brad Gibson, who used computer modeling developed by me and Kate Hensel.
So, how does the map of livability work?
The map shows conditions within the galaxy at different times and places. The x-axis is the distance from the center of the galaxy, and the y-axis shows the variation of time from the birth of the galaxy to the bottom, at the bottom to the present time at the top. At the bottom left we have a red region, which is representing an intense burst of supernovae, massive stars exploding at the end of their lives, which is bad news for life because the radiation they produce would most likely kill the life nearby.
In the blue region in the mass, the galaxy is still mostly hydrogen and helium, not conducive to the formation of rocky terrestrial planets. Some planets do not form until there is sufficient buildup of magnesium, silicon, iron and oxygen made by the various stars.
As time progresses, supernovae keep the center of the galaxy sterile, and the outer region is still too metal poor until stars that are producing metals have evolved. Finally, as we reach the green area about 7 billion years ago in 8 kiloparsecs, from the center, there is not too much supernova radiation and enough metals to form rocky planets such as Earth.
So far, have you found any planets that might contain extraterrestrial civilization that we can or may soon be able to communicate with?
Kepler 22b is located 620 light years away. Also, the Kepler telescope has discovered several other planets which may contain liquid water. The Sun Kepler 62 has 2 planets, Kepler 62e and Kepler 62f, orbiting in ocean-friendly orbits around the star. And another star spotted by Kepler, the Kepler 69, appears to have a planet in a habitable zone.
What are your hopes for this research as a whole and its contribution to the society?
An astronomer's dream scenario is to find life and study it up close. In the words of Seeger, we want to lay a path for the future, so that when people figure it out, they can go there.
Thank you for joining us today on The Breakfast Show.
Yes, thank you for having me on your show. I'll be back.